So it's now time to talk about for loops. So one of the reasons that computers are so useful is that they can actually repeat an operation multiple times very quickly. And this of course removes the need for a human to perform a repetitive task. Now we've seen the for loop in earlier examples, but now it's time to look at them in more detail and actually explain what was happening. So what a for loop does, it actually takes a range of values and assigns them one by one to a variable. It then executes a block of code once for each value. So for a simple example, we're going to have a go at printing out the values from 1 to 20. So the format is we type in the for keyword for I in range 1 comma 20 in brackets. Then we indent the code. This is the block that we want to have executed once for each value. So print I is now replacement field, so it should have been a double quote there at the start, dot format I. Format I. That's the simplest example. So again, what we're trying to do is go to get the values from 1 to 20. Now when we run that, you can see what's happened is for each value of I, we've actually got the value I is now 1, 2, 3, 4, 5, right through to 19. So it didn't go through to 20. Now, if you think back to this, you remember how our string slicers that we used return the characters up to but not including the end number? Well, ranges work in the same way. The last value specified is not included. So effectively, the way to read this for I in range 1 to 20 would be to actually say to yourself, I'm going to actually loop through the values 1 to 19. So the computer will actually repeat this code in here in the block, in this case 19 times, and incrementing the value of I each time. So the first time it runs, you can see I was set to 1, then I is set to 2, I is set to 3, and so on and so forth, right through into 19. Now we're going to talk more about naming variables in a later video. Up until now, we've just used simple words that describe the value that we've been dealing with. And normally you should avoid using single character names for variables like we've got here, like I, because they don't really give any indication of what the variable is for. But there is an exception to that, and loop control variables are one of those few places where I and J are acceptable. I is taken to be short for index, and the convention is that it is an acceptable name in a for loop. So when you are creating a for loop like this, using I is quite okay, and you'll find that there's a lot of code out there that actually does that. So another example of this, we can actually see the variable used as an index in the next example, which I'm about to type out, where we print each character in a string once at a time. So I'm going to actually just put that in the next line, being sure to go to the start of the block and not to indent it. So we're going to type in a number. Number equals 9, 223, 372, 036, 854, 775, 807. Then what we're going to do is we're going to put for I in range 0 len, which stands for length number, colon again, and we print number I in square brackets. There's a couple of things here. We've introduced a new function. This function here is called len, which is an abbreviation for length, and it actually returns the length of a string. So how many characters actually exist in that string. So in this case, it should actually return 25 if I've counted correctly. But with that said, the way that we actually access individual characters in a string, they actually start from 0, in this case, to whatever the length is minus 1, so 24 in this case. And because we established earlier that when we put a range in, we only go up into 1 less than the final number, we know that in this case, the len number is going to be correct because it's only going to go through and process up to 1 less than that final number in the for loop. So that's actually one of the reasons why the range runs up to but not including the final value. So in many other programming languages, the loop would have to be specified as from 0 to, and you might have to do something like this, len number take 1, because you'd have to cater for the fact you're starting from 0 and not starting from 1, as you can see in the example up here. But in this case with Python, you don't actually have to do that because, of course, we established that when you use a range, it actually finishes at 1 less than the number you specify anyway. Basically, it works more how you'd expect, and you're freed from having to consider whether you need to put this minus 1 and other such trivia, which is pretty cool. So if we actually run this now, you can see what's happened here. Each time we've gone through the loop, it's actually printed out one element of that string. And by using the square bracket, what that is saying is it's print the character at position I. So we started on the first time position I had the value of 0. So position 0 is 9. Next time it goes through in position 1 is the comma, and so on right through to the end. And we should have an 807 on the end there, the last 3 digits there. So you can see this is working quite nice, and it didn't crash or anything like that, and it actually come up with the right number. So that's one example, but let's just take this also to the next level. So let's just imagine that you're processing data that someone else has exported from a spreadsheet program. And let's just say that the spreadsheet was set to display numbers with commas or some other separator. Like in Europe, for example, it could be a full stop or a space. Normally, before we can process these numbers, we'd have to strip out the separators. But there's other ways to do this. And one way could be to check each character and only print it out if it's one of the digits from 0 to 9. So what we could do is actually take this code again. I'm just going to copy that and paste it down here. We leave the same for range in here, but we add another test here. And the test we're going to add is if number I in square brackets in a string 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If that's the case, and then we come back onto the print line and we actually indent that because we only want that executed if this actually returns true. So if you remember the in function, it returns true if whatever we're testing on the left-hand side is actually in whatever's in the right-hand side. So in this case, we're looking for the element, in this case 9, and is it in that 9? Yes, it's going to actually print it out. So what this should do is actually go through and print all the numbers, and it should actually skip the commas because, of course, a comma is not actually in this string. So let's just run that and see if it works. And what we should probably do is just to make sure, we'll just comment that out for now and run that again. And you can see that it's now successfully 9223 372 036 854 775 807. So it successfully skipped anything that wasn't a digit from 0 to 9. Now, one of the disadvantages with that is you notice that when you're using the print, automatically Python's actually adding the end of line character. So it's actually starting on a new line. So we can actually stop that if we want though, because there's actually syntax, and you may have actually seen this when you're actually typing a comment after a number. So if I go back and enter a comma there, you notice how this comes up automatically. IntelliJ is saying there's some other options here, and by default, end equals /n, which is a new line character. So that's what happens automatically, and that consequently each time it's hitting a number in the loop, is actually, when we're doing the print, it's actually skipping to the next line. So we'd be providing, of course, the first parameter, which is obviously the object that we want printed. But as you can see on the screen, we can also specify a separator and a value for end. So we're going to come back to separators, and the last two options, file and flush, will be covered when we talk about file IO in a later video. But the end parameter is the one that's interesting here though, because at the moment you can see that it defaults again to /n, which is new line. But we can actually override that. So for example, if we set that to an empty string, then a new line is not going to be started after each character. So what we could do is we could type something like end equals single quote, and that's overriding the standard n equals /n. And what we should see when we run it is the numbers now appearing from left to right because there's not a new line automatically being added each time the printout's made. Now, if we wanted to use the number that we've come up with for performing calculations, what we could do is we can concatenate each character onto the new string and then convert the final thing to an integer. So we'd have to initialize a string variable to hold the digits first, or Python will give an error because it obviously won't know if the plus should attempt to perform an addition or concatenation. So the way we'd do that is we'd come back up here and we'd type something like cleaned number equals double quotes. So that's what we're going to start with. We're going to leave the loop as it was before. We're going to leave the if there as well. But instead of printing out at this point, what we're in fact going to do is we're going to type cleaned number equals cleaned number plus number I. I'm going to get rid of that print. Go back to the left. So it's going to go through, and each time it finds a number, it's going to add only that digit to the cleaned number string that we've actually defined on line 9. So now what we want to do is convert that to an integer. So we type new number equals int clean number, and I could type something like print, because as far as Python is concerned, this is now a number. Print the number is format new number. So if we run this, we get the number is 922 blah 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 807. So as far as Python is concerned, that is now a proper number. So that's how you'd actually go about converting from a string and then actually building up a number that's actually in a string and then converting that string back to an integer. The thing here is that you need to actually be very careful with your indentation, because we're nesting blocks within blocks, and the for loop contains an if block, which contains the block that performs a concatenation. So if line 15 is actually indented by 4 or 8 spaces, then the code's still going to work, but new number is going to be assigned a value each time through the loop. So in other words, if I actually tab that, like so, and actually run this, now we still get the same result, but what's actually happening here is each time in this loop, new number has been assigned that value. And, it doesn't make us really, it's not really a problem here when we've only got a few numbers to deal with. But if you can imagine that if we had 10,000 numbers to actually deal with, you're actually repeating this assignment of the value int clean number each time we actually run. So it's a lot more processing. So the end result could be significant delays you're introducing, even if the final answer, as you saw, was still correct. So in this case, it's far better to actually have that calculation to occur only once, and that's after we've been through the entire for loop and we've built up the entire clean number string, perform it once, as opposed to actually performing it each time through the loop. Now, note that this is a specific example where our original number came from a spreadsheet program. We knew that it was a valid number that that happened to contain some extraneous formatting. So this code that we've actually written wouldn't be suitable for validating numbers that had been typed in a keyboard, for example. And also it wouldn't be suitable if the spreadsheet contains scientific data where the numbers could be in an exponential or scientific format such as 1.353e plus 18. So we're going to be looking at catering both of those, or catering for both those situations in future videos. So I'm going to end this video here. In the next video, we're going to continue with our discussion on for loops. So I'll see you in that next video.